All right, ladies and gentlemen, let's go ahead and get started with Unit 3.6. On top of our Unit 3.6 notes, we do have our warm-up for today, which is solve a system of equations using inverse matrices. Again, this will be great practice for you guys. As we take a look, we want to grab our coefficients in front of x and y. Again, I'll always label that matrix A. So as I go across, that's 3, -1, -2, and 1. Then we grab our constant matrix, matrix B, we'll call that 8 and 4. That's a 2 by 1 matrix. So here we go. We grab our fancy calculator. And if I want to solve for the matrix X, the variable matrix, we're going to do A inverse B on our calculator. So here we go. You got to press second inverse is the matrix menu. We want to toggle on over to edit. We got matrix A is a 2 by 2, and then type in those numbers. We got 3, enter, -1, enter, -2, enter, and 1, enter. So 3, -1, -2, 1. And then I'm going to press second matrix again, so the inverse button. We're going to edit matrix B. That is a 2 by 1. I got 8, enter, 4, enter. So I type those guys in, and then I go back to my home screen. From there, I go second matrix. We want A. Press that inverse button right there. And then second matrix, we go down to B. And there's our answer. So again, we get X, Y, and we get 12, 28. I usually like having you guys write that as a coordinate point. That's 12, 28. That's where those two lines intersect. And again, just one more time, that is a consistent system, and those two lines are different. They're independent from each other. All right, so the next one we have is a 3 by 3 matrix, and remember how hard that is to solve by hand. That's why using inverse matrices make it so nice. So again, we're going to go across and just write our coefficients in a 3 by 3 matrix. I've got 1, -1, and 1. I'll go in across, I've got 2, 3, and -1. And the last row here is 3, -2, and -9. Matrix B is our constant matrix, so going down, it's a 3 by 1 column matrix, 8, -2, and 9. And then if I want to solve for X, Y, and Z, I need to do A inverse B on my calculator. So let's go ahead and use the old calculator here. We're going to go and jump into matrix. We're going to go ahead and edit matrix A. It's a 3 by 3, and I've already pushed in the numbers. I've got 1, -1, and 1. I've got 2, 3, and -1. I've got 3, -2, and -9. And then I do it again. Second inverse is the matrix menu. I go to edit. Matrix B we said was a 3 by 1. There we have it. So 3, enter, 1, enter. We have 8, -2, and 9. When you do that -2, make sure you're using that little negative sign or you're going to get it wrong. Okay. Now the nice thing is if you've been doing this and you have the 84, you can toggle up and just grab that A inverse B. If not, you got to do it the old-fashioned way. If you have an 83, you got to press second matrix A inverse, second matrix, and toggle down the B. So A inverse B that way. So when we get X, Y, and Z for our variable matrix, we get 4, -3, and 1. Again, we want to write that as a coordinate point, 4, -3, 1. So 4, -3, 1, those are parentheses around that. Easy peasy. So that's great review from 3.5 using matrices, using inverse matrices to solve. And now we're going to kind of go back in time. And if you remember, we have done solving systems of linear inequalities already. This is nothing new. We did this last unit. So this is great review. So I'm going to do this one in blue here. So I've got y plus 1 is less than -x. So again, we're going to get y equals mx plus b. But instead of equals, it's going to be less than or greater than, less than and equal to, greater than or equal to. So to do that, I'm going to go ahead and subtract that 1 over. And if I rewrite it, I've got y is now less than negative x minus 1. I'm going to put my pencil on the b. I'm going to go down 1. And then my slope is down 1 to the right. So again, b is negative 1. My slope is also negative 1. Think of that as a fraction. Down 1 over 1, down 1 over 1. Perfect. Okay. Now I'm going to take a straight edge. You can use a card if you got cards. Your ID is great. And the other thing is we got to remember solid and dotted. Remember, if it's less than or greater than, we have a dotted or dashed line. If it's less than or equal to, greater than or equal to, it's going to be a solid line. All right, so as I take a look, it is not equal to, so I'm going to make a dotted or dashed line. Nice dotted or dash going all the way across, arrows on the ends of your graphs. And then this graph is less than, so if you remember, less than or equal to is below, looks like an L. And if it's greater than or equal to, I'm going to shade above. So a little trick, what I do is I'll find the y-axis, and I have to decide, well, if it's less than, I'm going to go down and shade below that y-intercept. So assuming I find the y-axis, if I said x, I apologize. I find the y-axis, and I shade down it. So this graph would be everything below that point. Some people use coordinate points and they check it. I just remember above and below. If I'm below you, I'd be going down right here. Next, I've got y is greater than 1. That goes back to Vux Hoy. If I have a y equals, and in this case y is greater than or equal to 1, we know we have a horizontal line, and that is at 1. So I'm going to go ahead and graph that. It's equal to, so it's going to be solid going across. This is my Indiana Jones card going across, so it's nice and pretty. Arrows on the ends. And then I have to figure out greater than. Again, greater than is above. Okay, so greater than is above. I find my y-intercept, and I shade up the y-axis. Okay. Quiz or test, I should be able to tell what your final answer is. And a system is, again, an and. So we want to find the overlap. I want to find out where the blue and green match up, and that's all right here. Anything in this little area is going to be a solution for this inequality. Let's take a look at the next one. The next one I've got x is greater than 2. Vox. Vertical, undefined, x equals. So we have a nice vertical line. I'm going to go and find 2, 1, 2. And I'm going to make a nice, pretty vertical line. It is not equal to, it doesn't have the bar on the bottom, so this is going to be a dashed line. So don't forget that on a quiz or test. You're going to lose a half a point if it's wrong. Greater than, a greater than symbol, when it's a vertical, greater than is pointing to the right. So my shading for this one would be all the numbers that are greater than 2. That would be like 3 and 4 and 5. So my shading would be to the right. So I do that lightly. Then I'm going to graph this one. Y is greater than x minus 2. I'm going to find my b. That's negative 2. So I go down 1, 2. And then my slope again is 1, or think 1 over 1. So I'm going to go up 1 over 1, up 1 over 1. Man, that's fun. Rise over run. That was greater than. So again, that is a dotted or dashed line, if you will. Dotted or dashed. Dashed or dotted. And if it's hard to tell, you can always write dotted on a quiz or test. The last thing is I look, it's greater than, and greater than is above. So I find the y-intercept, and I'm going to shade up the y-intercept. Up the y-intercept. Above, above, above. When we're solving systems, we're always looking for the overlap. And anytime two lines intersect, there's always four sections. This section has nothing. This section is only blue. This section is only green, and this has both. That's what I'm looking for here. Dash this line. So those are my solutions all right there here. Okay, quiz or test, I should be able to tell which is which, so make sure that's darkened in if you're just using a pencil. All right, we're going to do just a few more. I'm going to do number 3 real quick. And let's go ahead and get that one started. Here we go. I've got y is less than or equal to 2x minus 3. I'm going to graph my b. So b is negative 3. So I'm going to go down 1, 2, 3. And then my slope is 2. So think 2 over 1. So I'm going to go up 2 over 1. Man, that's fun. Rise over run. And I'm going to have equal to, so it's going to be a solid line. Connect dots. Solid line. And then it's less than, so again, that's below. So sometimes it's hard to tell, so that's why I find my y-intercept, and I say, well, if it's below, less than, I'm below you, I'm going down the y-intercept. So I would lightly shade that. Last one we have is y is less than or equal to negative 1/2 x plus 2. B is 2. Go up 1, 2. And I'm doing my slope. This time my slope is negative 1 over 2. Positive goes up, negative goes down over 2. Down 1 over 2. Rise over run. This one is less than or equal to because it's equal to. The bottom bar means this is a solid line going across. Arrows on the ends. And then I have to decide my shading. Again, less than is below. So find that y-intercept and go down. Go down the y-intercept, the y-axis. Well, my answer again is the overlap, the intersection of blue and green. And if you guys can tell, right here is blue and green. So all of these coordinate points are solutions for the blue and the green one, including on those lines. Last but not least, and this is getting you guys ready for tomorrow's lesson, the linear programming. We're going to start seeing 3 of these, and just treat it just like you've been doing. I've got x is greater than negative 1. This is Vux. We got a nice vertical line here. It's not equal to, so I'm going to do a dotted line here at negative 1. Then I've got y is less than 2/3 x plus 2. So this time I'm going up 2. And then my slope is 2/3. So I'm going to go up 2 over 1, 2, 3. Again, those are not equal to, so I'm going to use those nice dotted or dashed lines. Before I go any further, let's go ahead and shade now. X is greater than negative 1. Again, that is because it's vertical, it's either going to be right or left. Because it's greater than, I'm going to shade to the right for the blue. And then the green one is less than. And this is an oblique line at an angle. So that means I got to go below that one. So find the y-intercept and shade down or below that line. Okay. Well, if it was just blue and green, I would have all this overlap over here to the right of blue and below green. But now I've got one more. Look at this guy. I got one more line. Again, get it so it's y by itself, because there's a y and an x. Get it so it's y equals mx plus b. And now I've got y is greater than 4/3 x. This time I don't see a b. So that means it's like a plus 0. So B is 0 there. So start right at the origin. And now my slope is 4/3. So I'm going to go up 1, 2, 3, 4, and over 1, 2, 3. If you want to do it again, 1, 2, 3, 4, over 1, 2, 3. This one is greater than. It's not equal to. Again, we're going to do a dotted or dashed line here. Quiz or test, if you're like, made a mistake, maybe you made this all solid, well, you could write dotted, and that'd be fine. Sometimes people make mistakes. I even started and made that little solid. Okay, but again, I fixed it. But just in case, quiz or test, you make a little mistake, go ahead and do that. Last but not least, we got to shade this guy. So greater than is up. So again, sometimes these oblique lines is hard to tell what's above and what's below. So start at the y-intercept, and above means I'm going up the totem pole, this y-axis. So I would shade everything above that line. Okay. All right. So my answer, if you can kind of tell, I've got to be to the right of blue, below green, but above orange. And if you can kind of tell, it's just this little area right here is to the right of blue, below green, but above orange. It's just this little triangle here. All right. Eventually tomorrow we're going to be talking about finding the intersections of these points and eventually finding some of the maximum and minimums of those points. But that'll be for tomorrow as we start looking towards the future here. Ladies and gentlemen, that is it for today. I went ahead and skipped number 4. If you want to see 4, stick around, but you guys are good to go. Have a great day. If you're sticking around and you wanted to see number 4, here we go real fast. I've got y is greater than negative x minus 2. Remember, that's in terms of y equals mx plus b. But b is negative 2. So I'm going to go down 2. My slope is the number in front of x. That's negative 1 over x. When you're talking slope, don't include the x. It's just the number in front. So I would go down 1 over 1, down 1 over 1, down 1 over 1. It's not equal to, so that would be a dotted or dashed line. And then shaded greater than is above. So find that y-axis, shade above that y-intercept. Last but not least, I've got this one right here. Y is less than or equal to 3x plus 2. Again, y equals mx plus b. The b is the last number, 2. So I'm going to go up 1, 2. And then I'm going to do my slope. My slope is 3. Think 3 over 1. I'm going to go up 1, 2, 3, and over 1. 1, 2, 3, over 1. This one is equal to, so I'm going to have a solid line going with this one. It has that bar on the bottom, so this thing is a solid bar. Bar, solid bar. And then again, we want a graph where it's less than this line. So find the y-intercept, and it's below. This one's nice and easy because we want to find where the blue and green meet. So as I look, the blue and green meet right here, where it's above blue, but below green. Where the blue and green meet. All this guy here. Final answer. Ladies and gentlemen, that is it for today. So we should be good at graphing a system of inequalities. I'll be back tomorrow. You guys have a great day.